but the book goes into much more hairy scenarios than the movie is able to. I gotta turn off my waiting room unless I already have two people. That's pretty cool. Oh, admit Noah, get him in here and play a sound. Good to see you, Noah. Let's go. Let's go. All right, guys. So like I said, 10:33. I'm gonna stop at 11. If I'm talking at 11 o'clock, feel free to holler at me so that we stop and you have plenty of time to work. If you didn't see my announcement, top three priority things to do today are Unit 5 tests or Unit 4 tests that I put an extension on. That extension goes to tomorrow night at midnight. It is a pain in the butt to have to reopen it for somebody to do a test. That's why I extended it. Everybody do that test. Do that test. Knock it out. Feel free to use your resources that you need to get the questions right. And the essay really goes with the El Nino La Nina activity that we did from a couple weeks ago. So a lot of your research could match up with that as well. Second priority is your APID test from last week. No, I mean, I don't really have a deadline for that, but you need to get it done so you're not doing two APID tests back to back, because you'll have your next APID test next Friday. If you need a packet, I have some here at school. If you come to school, pick one up, and I need to add that to the Canvas. I'll do that this afternoon as soon as we're off. I promise about that. Sorry about that. And I'll get the APID. APID packet 6 is what we're working on right now. It's the packet up here.
Last week,
the test is APID packet 5, yes. Okay, and a bunch of people have done it. So, and then the third priority thing is the ecological footprint activity that's in the modules on Canvas. It's pretty quick, knock it out, and it'll help guide our conversation in the coming days. All right, so we got to roll through this stuff. This unit, it is, like I said, a very broad unit with a whole bunch of different things. We'll try to talk as much as we can about it. If you have any questions, feel free to let us know. These notes are posted online already if you want to grab them. All right, so we talked about GMOs and green revolution yesterday. We kind of mentioned this already, creating crops that are high yield variety so you can make a whole lot of food in a smaller area. It increased food yield, and it's what pretty much allowed us, along with fossil fuels for transportation, it allowed us to blossom to 7 billion people on our planet. Prior to the green revolution, prior to the industrial revolution, you had, 1 billion people or so was our carrying capacity for Earth. But people don't like to see people dying, and so we, pretty much beat our ecosystem and created a situation where humans have been growing exponentially for the past 150 years. Now, obviously, that is not possible for the next 150 years because, unless we really come up with an entirely new revolution, which we might be able to, you're talking about, 20 billion people on Earth or more. And there's just not enough space to grow food for that many people. All right, let's keep it on rolling here. Looking at how hybrids are made and things like that. Most of your food crops that we use today are hybrids or either genetically modified. Very few are their original wild form. If you look at like the history of broccoli or like the history of different melons and like how, humans have hybridized them to be good for human consumption. Watermelons especially, like if you look at what a watermelon looked like from years ago, you're talking about the edible parts really, really small and you have a whole lot of green mixed into it. Whereas now you have very small rind and a whole lot of red meaty watermelon because they've been bred to do that. The only difference between hybridizing and genetically modifying is that you're going in and changing the genetics immediately versus changing the genetics over long periods of time by allowing plants to grow in different ways. As we already mentioned, genetically modified organisms, GMOs, crops that have genes for all kinds of different things. They have genes for drought tolerance, pest resistance. They can have genes they can be bred to resist a certain herbicide. So you have one of the most common things that they do now is you have a plan. We'll talk about this in a little bit as well. I think that you don't want weeds growing in your crop, so you want to spray herbicide. Herbicide kills plants, but you don't want it to kill the plant you're growing. So you modify the plant you're growing to be resistant to the herbicide you're spraying. So when you spray a herbicide on your field, you kill everything but your crop. Roundup Ready is one way to think about it like this. Roundup is obviously a herbicide, kills plants. If it's Roundup Ready soybeans, it won't be killed by Roundup, and so you can spray your crops with that. Another thing about GMOs is that it creates clones, and so your entire field is genetically identical, which is good if everything's working, but it also creates susceptibility. If something kills one of your organisms in your crop, it's going to kill all of them because they're all genetically the same. So it's the risk reward. Fertilizers are anything that you can put on a plant to help it grow faster. You have organic fertilizers like manure, poop, and compost. Then you have synthetic fertilizers, things that are just going to straight put the chemicals that you need on those crops to allow them to grow. Increasing yields, gives more profits, things like that, pretty straightforward. But then you have to worry about where that fertilizer is going. If you spray it on a field and it rains, the fertilizer is also going to go in your local waterways. You can create algae blooms, things like that, and all kinds of different problems. Irrigation, you wrote the essay on. If you've already done your APID number 5, you wrote the essay about it. But irrigation is how you get water to your fields. In some parts of the world, you don't really have to worry about irrigation. When I go to Guatemala, there's no real setup for irrigation in most of the fields because every afternoon it's going to rain during the growing season. And so you have certain parts of the world where you don't really have to worry about irrigation, but then you have parts that irrigation is essential. North Carolina is kind of in between. North Carolina, farmers use irrigation systems, but it is not as essential as places like Kansas and Iowa and Nebraska, where you can go weeks during the summer without any rain, and you have to have some irrigation to keep those crops going. So irrigation can use up your groundwater, especially if it's an aquifer, which is water trapped under rocks. And then overwatering can also screw up your soil, can increase the salt level, can make it so roots aren't able to get oxygen. So you have to have this balance of how do you irrigate and how do you use herbicides and pesticides. Pesticides kill things that are going to eat the plants, kill your insects usually, but not always. Sometimes weeds that can choke out your plants, or rodents that like voles and things like that can be in your crops, eating your plants. There's all kinds of different things you can do. Once again, the problem usually occurs when the pesticide goes places other than where you want it to be, or the biomagnification that takes it other places. Like you kill those beetles, but then the pesticide-ridden beetles get eaten at the next trophic level, and then you magnify that, and you end up killing these hawks that are a key part of your ecosystem, but you don't want to kill them because they're not affecting your plants. So, all kinds of different things going on with that. All right, so what are these things? So we just went through the things. Now let's say what they're doing to us, and we kind of mentioned these, and we might go fast on some of these. Monocropping, we already kind of mentioned. If something kills one part of your crops, it kills them all. It's cheaper to grow, it's easier to grow, but it is risky. And depending on what type of soil you have, you could ruin your soil, plant the same thing at all times, and it decreases habitat diversity. So you only end up with one type of thing. We till the fields to be able to plant. The natural ecosystem can get disrupted. You can cause more erosion, but it allows you to be able to plant a little bit better. You can also, over long periods of time, tilling and retilling over and over and over again can end up really damaging the topsoil and getting rid of your organic matter. So showing you an example here, you have your no-till ecosystem with all kinds of diversity. all kinds of different things going on. Then you have your tilled ecosystem that creates this very stratified, uniform, non-natural scenario. Slash and burn is something you don't really see in the United States, but in parts of the developed world, you don't have the machinery to be able to just cut down trees and then till these really complicated ecosystems. And so the solution then is to just literally cut down what you can and then burn the rest. Once you burn the rest off, then the theory goes that you'll have ground and be able to plant in it. The problem is that it's just not successful at all to be able to do that. So yeah, you burning stuff can make plants go into soil. Sometimes if you, that's the thing about it is there are certain ecosystems that do depend on fire to reset and to be healthy. The western part of our country, you guys hear all kinds of things about California wildfires and things like that, and Oregon and Washington. And that's sad because people's houses are getting destroyed and because, with climate change, maybe they're happening a little bit more. But wildfires are a normal part of the West Coast of the United States. Before anybody was living on the West Coast of the United States, there were wildfires that allowed the ecosystem to reset and be, and it is a wildfire dependent zone. Because you'd get dry and then lightning would strike and start a wildfire, and then your ecosystem could start over again and stay healthy. It'd be kind of like the ecosystem breathing. The problem is that now people are living there and they don't want their house to be a part of their ecosystem resetting. And so you end up with this kind of balance between, well, are we doing this for the good of the ecosystem and the good of our planet? Or are we doing it because we want people to live there? It's kind of, in North Carolina, we don't deal with it too much, but we do deal with something similar on the Outer Banks. We do all kinds of dredging and moving soil around on the Outer Banks to keep people's houses protected. But the Outer Banks, if you look at geological time, are very dynamic. They move, they ebb and flow. The inlets close up and then open up in a different place. It's just what the Outer Banks do. So when we really change what we're doing on the Outer Banks, are we doing it for the good of the world, or are we doing it for people's houses? And so you have to maintain that balance of what we're doing in that situation. So once again, slash and burn, terrible for the atmosphere because you're just throwing all of these gases into the air with the snap of a finger. And then you, of course, deforestation. And of course, we're talking about the developed world. Where in the world? Where? Geographically. Southern hemisphere, usually more equatorial or more polar? More equatorial. So what biome? Tropical rainforest. What do you know about the soil in the tropical rainforest? Very good. Absolutely. That is a limiting factor of the tropical rainforest. So when you burn down a tropical rainforest, it's one of the tragedy of the commons things. It makes logical sense. I want to plant crops to grow for these people, just like they did in the whole rest of the world. But when you burn it down and when you do this method, you just don't get the same situation because, burning down a forest in North Carolina, you can plant a field because you have this dark, nutrient-rich soil beneath our feet. If you do the same thing in Honduras, you're going to just end up with a desert and you're going to fail at trying to plant things. Also lowers albedo, global warming. We've already kind of talked about that. Looking at synthetic fertilizers, we already mentioned this with the runoff. Water going into the soil, carrying those nutrients away into the groundwater. Leaching is from the soil to the groundwater, and then runoff from the groundwater into creeks and streams and ponds. And that's the word, do we remember right there, eutrophication from our essay from a while back? Eutrophication, where, it's another one of the things that sounds like it'd be a good thing. Fertilizer, growing plants in streams. that sounds really, really good. The problem is the types of plants you're growing and the types of animals that are going to eat those plants that completely disrupts the ecosystem. And you could actually end up with an oxygen sapped waterway because you put plants in them that are going to make oxygen, but you're putting so much more things in them as well. Right, looking at irrigation, you know, we see these are circle irrigators here. These are other types of irrigation. One word that that got brought up on an essay from a couple is this test essay, isn't it? The test from last Friday, the drip irrigation question, drip irrigation. Yeah. So gravity irrigation is any time you're depending on gravity to get the water onto the ground. So spraying into the air, or whether that be shooting it out through a sprinkler or having it with a giant like machine like this that you'll see sometimes in the field that circles around. You know, it is the opposite of flood or furrow immigration or irrigation. This is where you just let the field flood, let the water come in. You know, rice does this. You know, things that are very, very water resistant, you can just flood your field. But it also is going to, you know, if you try to do that, tobacco is going to die, or corn, soybeans. Flood irrigation is not the greatest here. It's very, very efficient but you do get runoff and evaporation. Furrow irrigation is where it's kind of like flood irrigation, except for you have your plants up a little bit higher, so you have the waterways kind of beside them. You have this trench. You have spray irrigation, probably the most common way that we irrigate here in Eastern North Carolina, if we do irrigate. It's very expensive because it takes all the movement and sprinklers and things like that. It's more efficient than flood, but it is less efficient than drip irrigation. You still do get some evaporation because you can't, it's hard to turn the sprinklers on slow. You either have them on or off. And so you spray and then you let the water sit there. Whereas drip irrigation can kind of just, it's called drip irrigation because it drips. You're constantly delivering just the right amount of water. So you don't have to worry about waterlogging, but it's very, very, very expensive. It's very expensive because you need to put a tube.
Fire.
Oh, Lord. Talk. Okay?
Nothing, that's all.
I didn't hear what you said.
Who said hey?
Somebody yelled. I didn't hear what they said. Y'all need to stop coloring. There, so drip irrigation, 95% efficient, but it's also the most costly. So, you know, irrigation is a thing. The papers I've read on irrigation are very good so far. So why you don't want waterlog? It's pretty straightforward. It's hard for the roots to work. They can't get oxygen. And so, yeah. Soil salinization is where you get your salt levels too high. It's where water either from saltwater sources bring it in, or from just having too much water can get the salt out of the soil that it uses normally, and have that salt kind of spread around. Anybody who's ever tried to grow any plants knows that salt is bad news. If you want your grass to die, you sprinkle some salt on it and it'll be gone. All right, flipping the script just a little bit to global water use. The majority of water for our planet is agricultural use. You know, you have all kinds of little public service announcements. I know I had them growing up. I know we talked about them in school, where when you brush your teeth, you cut the water off. You save water when you do all kinds of different things. Don't take long showers, on and on and on and on and on. And we'll talk about that when we talk about water resources a little bit later and water pollution. But when you look at the data, municipal water use, which is me and you, is right around a 10% of global water use. It's going to be even less in industrial part of the world because you have more agriculture and more industry. The great majority of water use for our planet is agriculture. So when we talk about water use, really we're talking about the food we're eating more than the water we're using or the water we're drinking. All right, so looking at groundwater is water in the ground, just exactly like it sounds. We are blessed in North Carolina to be able to dig a hole about 12, 15 feet deep, and you got water. Put a pump on it, you got water, safe, clean drinking water because it's naturally percolated through the soil and cleaned out unless it's contaminated from something else. Aquifers are underground deposits, which are usually going to be underneath a rock source. So very, very clean water coming from way up in the mountains, usually very cold. You can drill down through what they call in North Carolina is drilling a deep well, where you're going below the bedrock down to the next layer of that confined aquifer. Groundwater's recharged through rain, through soil, pretty straightforward. And then our confined aquifers are going to recharge longer because they're getting their water from at higher elevation. So it takes longer to recharge it. So if you pump from an aquifer, you can dry it up and it takes a lot longer for that water to get back. A deep well. Deep well goes to an aquifer. A normal well will go just to the groundwater. We use a combination of both for our municipal water. We kind of mentioned that before. Most of our water does not come from wells anymore in East North Carolina, but instead the towers, which come from wells. So you look at depletion of aquifers. If you've ever seen they're not really memes, but pictures on the internet about the ground sinking in certain parts of the world, it's because of depletion of aquifers. The water is going down, and so the soil is getting more compact. So if you have, a cone of depression about around where you're pumping, after heavy pumping, so you get this agriculture in the middle that pumps lower, and you can dry up the wells of their neighbors. You can also get saltwater intrusion if you live close to the ocean, where the salt water underground mixes with the fresh water, and that can cause a real problem because you don't want to be drinking salt water or using it to water things or positive things. 10:55, sound good? Okay. Any questions for my folks at home? Everybody know about 3 things I need you to do? All right, we are rolling through this. I got a thumbs up from Noah. That's impressive. Good job, bro. All right, so we'll be rocking and rolling. If you have any questions, send me an email. And tomorrow, we'll just keep on rolling with this. Make sure we'll probably talk about the ecological footprint tomorrow. So try to have the ecological footprint done if you can by tomorrow, because it's a pretty quick little activity. Have a great day, guys.